Hi to all. Let's wait a few minutes so that people can join us. So it's exactly 10 o'clock, but let's give few minutes um, for people to join. So as I said, just let's give few minutes for people to join the Zoom space, and we will start immediately. So I can say also a few things so that you will not get bored waiting for us to start, though I'm sure that some of you may be checking emails or other messages. Um, Officially, this event takes place after the completion of the Shift Hub project, but it is part of the activities that we will keep on taking place, the demo days. So, while you get paid from a project, you may do many things that may not necessarily make much sense, but they are part of your contractual obligations. So, once these external funding stops, you focus and concentrate only on the things that make sense, are important, and have some value. So, demo days have been one of these things that for us in the University Hospital of Cologne, but also as a consortium, they were very important for us to come up with a good concept, and therefore we continue. And today we have three startups. All three startups are from Estonia, and all three startups come from the TalTech ecosystem. TalTech is the Tallinn University of Technology, and I think that it's okay if we now start. And my name is Adamantios Koumbis. I am with the University Hospital of Cologne, the Biomedical Informatics Institute. And as I mentioned, this demo day is dedicated in three startups that come from the Estonian, the TalTech ecosystem. And now I will ask Leonie Fath, my colleague from the coordination team of Steinbeis Europa Zentrum in Germany, to say a few things about the project. And next, I will ask Dr. Gunnar Piho from TalTech to also introduce himself and say a few things about the TalTech ecosystem. And then we will start with the most important thing, which are the demonstrations. Okay? So, Leonie, please, the floor is yours.
Thank you very much, Adamantios. I will quickly share my screen. So you should now be able to see my presentation, correct?
Yes, yes.
Great. So my name is Leonie Fath, and also welcome from my side. I'm project manager at Steinbeis Europa Zentrum in Germany. As Adamantios already said, I'm part of the coordination team in Shift Hub and also work package leader. And I would like to give you a very brief introduction into our Shift Hub project. And in Shift Hub, our aim over the last 3 years was to foster the development and uptake of smart health technologies. So basically bringing smart health innovations to people. And our project was a coordination support action funded by the European Commission. It ended last month in December 2025 after a duration of 3 years. And the consortium consisted of 12 partners that represent important stakeholders and expertise within the smart health ecosystems. So the consortium consisted of knowledge providers. So here we have our 3 universities as partners. We have 4 organizations on board as innovation intermediaries with experience on how to support and connect diverse stakeholders. Then 3 technology providers providing different tools for our services, and 2 partners specialized in engaging our target groups, including small and medium-sized enterprises and technology providers, as well as patients. And together with our partners, our goal was to facilitate the development, to ensure the promotion and foster the uptake of smart health technologies and services. And to reach that goal, we established our hub to provide services to all stakeholders of the smart health innovation ecosystem. And our ShiftHub service offer is centered around 3 pillars. I would like to give you a short overview on the different pillars. So the different pillars all represent 3 key values that were designed to meet the needs of our stakeholders. These are either to build and boost your innovations, reflected in pillar 1, to connect and thrive collaborations, as you can see in pillar 2, and in pillar 3, to learn and grow your knowledge. So whatever the value is you're looking for, you can find the respective services listed in the different pillars. Even though our project ended in December, for almost all of these services, they will be either continued by the respective partners, or we have established replication opportunities to adopt the methodologies. And I would like to quickly go through the different results. So as I said, we have replication offers. So the results on the methodological approaches are available either on the comprehensive best practice guide or summarized in our best practice sheets. You can all find them on our project website in the resource section. And before I close the introduction into the ShiftHub project, I'd like to point out another key legacy, which will also be sustained after the project has concluded, and this is our ShiftHub community. And with the registration to today's event, you have already joined the ShiftHub community. This community platform is a dynamic online space with the aim to connect stakeholders across the European health ecosystem to foster collaboration and accelerate the adoption of smart health technologies and services. And currently, the community connects more than 800 international members, providing them, amongst others, a marketplace to showcase their solution and to find partnerships. Additionally, via the platform, you gain access to many events, such as our brokerage events, the B2B matchmakings, the focus group, and diverse workshops and other network opportunities. So, as I've already said, the community will be maintained by our partner, the European Digital SME Alliance, and therefore the community stay active, even though our project period has ended. And our consortium partners and partner organizations will, of course, also continue to use the platform to host events in the future, such as another demo day, other focus group events or webinars. So this will still be an active environment for you to use. And I would also quickly jump into the marketplace. So here you can showcase your offers, which can be either product, services, expertise, or partnerships, or investments opportunities. But you can also find project corporations. You also have the chance here to browse the offers of other community members, as well as reach out to any member by direct messaging. And this way you can connect with potential business partners or find collaborations for future innovations. So if that is of interest to you, I encourage you to explore the community as well as the marketplace. And other than that, I would like to hand over again to Adamantios to take over the moderation. Thank you for listening.
Thanks, Leonie. Gunnar, now it's you to present with few words about the TALTECH ecosystem. And so I think that it's not accidental that we have all three startups that come from Taltech, and we are here to listen to you.
Hello, everyone. My name is Gunnar Piho, and I'm from Estonia, from Taltech. And Estonia is a small country, 1.3 million, so it's like a small village. We have actually 5 universities. We have University of Tartu, then we have Technical University, also this is called Taltech, and then we have smaller universities focusing on educating teachers, educating agriculture specialists, educating art and music, and so on. So Estonia is a little bit as Estonia is small, it means we can act as a small laboratory. And approximately, beginning of this century, when Estonia was independent, Estonia started various, let's say, information technology investments to, for instance, government system, e-health system, and so on. And currently, Estonian e-health system is quite advanced. We started already in 2008. It was launched as a system, and currently we are one of the most advanced e-health ecosystem in the world. Now, some 5 years ago, we started together with Professor Peter Ross, who actually is one of the main actors in developing and organizing and so on the Estonian e-health system. We started a group called eMedLab. And eMedLab is part of Taltech. It's a research group in Taltech. And we have medical doctors, and also we have computer scientists. So Professor Peter Ross is medical doctor and also working for hospitals. He knows hospital management and hospital needs. I'm a computer scientist, but I worked more than 30 years in software industry. And so in 2015, we started this eMedLab. And actually, our motto is that if we do research, there must be 2, let's say, quality properties for any research. And one, the quality property is research must be publishable, and the other is research must be applicable. And this is why we are motivating our PhD students, our bachelor students, master students, always to do something real. Maybe not always, maybe it does not end with some kind of practical solution, but it gives something, some motivation for youngster to think maybe about even unicorn or whatever. And it helps in research, it helps in communication with companies, it helps also in teaching. So this is my short story. And currently, Olga Vovk, who is a PhD student of our laboratory, probably graduate soon. Igor Posenko, who graduated 2025, was also a PhD student, currently researcher. And also I will present some ideas what is related to eMedLab spin-off. At least we try to achieve something. So that's all, and thank you, Adamantios.
Thanks, Gunnar. So just only one comment about what you mentioned about Estonia being a small country. Myself, I have been also working in the past in Ireland, which is also comparatively to Germany a much smaller country. It's not as small as Estonia, but I think that sometimes countries that are small are only small in terms of size or population, but they are much more active and agile, and the human factor is much more mobilized, which is something that one needs when you deal with research, when you deal with entrepreneurship. So this is actually, Estonia being a small country is a virtue and an advantage and not a shortcoming. So that said,
yeah, this is Adamantios, what I told, that we can act as laboratory. We can do crazy things without not risking with huge amount of money. This is actually the situation. Yes.
Yeah, and the idea there, because this was something we discussed in the past, is that we can see and integrate you as a partner in some type of a living club experience for any type of innovations. They don't need to be only in the field of health. And that said, we start with CyberWise Space, which is a young startup, and its core asset is WiseSpace, which is a tool designed for non-technical users to securely de-identify healthcare data. And WiseSpace provides tools for personal identifiable health data detection, de-identification, and risk assessment. Olga, the floor is yours, please.
Hello, everyone. Thank you for introduction, Adamantios. And as Gunnar mentioned, I am one of the PhD students, and I also shared this vision of the product of research being not just research and published papers, but also working products. So today, I will show what is part of my research, what grow into the product. I will start with sharing my screen. I do have slides here. Yes. I will just make it full screen. Okay, hope you can see it well. So today I will be talking about WiseSpace, healthcare data anonymization tool. So starting with a problem that we have three parts of the problem. As first is limited healthcare data sharing, although secondary data use is beneficial for research, for policy making, for business. It has quite many issues with
Olga, your slides
privacy.
Not move. There is still this presentation, not presentation.
Okay.
Mode.
You don't see second slide, second page.
No.
Okay. Let me just start another way.
Now I see second page. Yes, now I see.
Okay, but it won't go this way. Okay. Maybe we can start prevent remove.
Now looks better.
But
Takes
now
this full screen mode.
it won't go like this. Sorry. Maybe I can just try. Okay, this one. Okay. You should see the no. Okay. Okay, let me just try slide from the file. Should work. Let me just check. Okay, let's try this one. Is it better?
Now
You
it's
should
good.
see
Yes.
the first
Thank you.
slide. Okay. Okay, I will. Still can see it? Okay, good. Thank you. So technical expertise is needed to make proper data anonymization to make proper security. And there are older and newer regulation in this field that include healthcare, which include European health data space and GDPR, General Data Protection Regulation. And by those regulations, healthcare provider must securely share data, and they must comply with those requirements, and challenging might be even more challenging. Sharing might be more challenging than before. Also, talking about healthcare data specifically, they have complicated structure. Sometimes part of this electronic health records might be unstructured and complex, and using general tools that are available on the market, it might be not possible because they will not work properly. And again, we will need to have technical expertise to make it work. So our solution Yes, our solution is a smart tool that simplifies data sharing and anonymization process that make it available for non-technical users. So it goes directly support healthcare data formats. It has risk assessment, risk analysis as a part of the flow, which helps users to comply with GDPR and European Health Data Space Regulation. And it can be integrated in the system, or it can be used as a standalone solution. Currently, it's web-based, so it's possible to try. And I will briefly go through the overview, and if we will have enough time, I can make a demo as well. So talking about general view, first we have short overview of main page. We have all main healthcare data formats supported, privacy first and risk assessment. So user can very simply upload data with drag and drop or with selecting files. And after that, file is analyzed, and we see that in current file, it works with large files as well. So this one is a radiology set, and it includes more than 20,000 records. It includes information about procedure, patient age, information about doctor. So this is in general gives user information about what is included in the file. And after that, we confirm that anonymization can start. So this is an example of how a record could look. So we see also some parts that are anonymized. It gives user information about what about what was done with file, and this file can be simply downloaded. And we do have included risk assessment and summary. So before summary includes processing time, format, how many records was processed, and all the necessary information if there were any errors or if everything went without a problem and all data fields were anonymized. And we also have risk assessment that with a simple score and with simple colors just show to the user if this data set can be further shared with third party or publicly released. It depends on how we want to prepare those files. So thank you for presentation, and I can, if we still have enough time, I can show.
It is a demo day. Demo is the most important thing, not slides. So please.
Yes, sure. I will do that. Mm-hmm. So let's see. Yes, you should see the screen now.
Yes.
So this is the main page as I showed previously, and we also implemented parts of what is required by GDPR, that we need to have proper legal basis for data processing. So here we also have confirmation, but first let's go together and select how we want to with whom we want to share this data. So let's start with research use. So it means that we will share data with trusted user, for example, for academic research, for clinical research, maybe a student who is working on master or PhD thesis. And we confirm the data, and now this enables, because before you cannot just simply upload the data. So let's, here I have prepared file. Okay. Here. So we have processing, and currently file is analyzed. So what I showed you on the slide, this is exactly the same, but it has like more information that you saw on the slide. So it has visit place and information about healthcare professional, about time, summary. So here we can adjust what fields we want to anonymize, what fields we want to leave on. Currently, I will just leave it as it is and select anonymization. It can take some time. Yes, it says that it's processing, because, well, file is a little bit big. So let's see what we have. So we can we can see the processing time. We can see like the summary of how fast it was processed and what data was anonymized, what was applied here. So we also can see a preview and risk assessment. I will just show you the file here. So I need to download it. Mm-hmm. Okay, do you see the file, or I need to share file separately because it's in my separate window?
No,
You don't see the file?
No.
You don't see the file? Let me just start share the file. Okay, yes, now you should see the file. So this file is in Estonian, but here we translated those names, so it will be a little bit more convenient. So this is the name of the procedure, and since it's generally the same well, at least so it's the same procedure for all patients. So this one was not anonymized, but in other cases, if there are some rare procedures, for example, or if they vary from patient to patient, this can be anonymized as well. So here we have a unique code, which is in like link for image. In certain cases, it usually, like for general use, it will be just deleted, but in this part, there was a request to make it pseudonymized. So we do have a link, and here we have also patient age. In general use, we will make it like age from let's say 70 to 75. If a patient is older than 88, it will be 88 plus, for example. But here we will just leave age as it is, so it depends on the patient. Here we have gender, it's both in Estonian, male and female. So place of visit, actually with place of visit, there are some, let me just show you. Yes. Some parts where address was also included. So if it's some small practice, we just deleted address here. For visit time, we keep it as it is, but it's possible in different settings that we change time and delete it. So for healthcare professional, in this case, it's changed to doctor, in this case, radiologist. What else about examination area? We also have a summary here. The summary is, yes, again, in Estonia, it's in free text. So we have keywords, we leave it as it is, but it has a keywords that our system is looking for. So we analyzed previously what personal information can be in this text, and sometimes it has names of the patient or doctor who performed this procedure. Sometimes addresses. So we delete this information, and other part we will just leave as it is. So that's everything about this file and about anonymization process. So in general, it has the settings that are set by the system. So user don't need specifically to adjust it. But if there are any preferences where users want to do some more specific types of anonymization, for example, some part of data needs to be kept, we are working also on more customized approach where user has more control over the system. We have 2 papers published about the system, and I expect some more papers also to be presented. And I think that's all from my side. I will be happy to answer questions.
And there is one question, Olga. Thank you very much. You can find it in the chat so that I don't need to read it loud. So it's from Helder Valera.
Okay.
And just have a look. It is, or I will read it. when an EHR
Okay.
is uploaded into your platform, data sharing already occurs. What technical and contractual safeguards are in place to ensure that no data is transmitted to third parties at any stage of the anonymization or processing pipeline? So, of course, in a demo, it's only what we understand there from what you saw there, because I don't think necessarily that people will be uploading their EHR systems and all the records there, but it's good if you see there the question and then come up with an answer on your own.
Okay. Thank you for the question. So, first of all, that this system works in a browser. So the system is like, let's say, limited, and I mean that yes, there are records and they do go to the system, but those records, they are not visible for our system, but only like all the processing is done within the browser. So the data is not specifically like stored in any other places. So it's processed and it's uploaded by the user, and that's it. So there is no specific place for data to be stored. It could be other thing when it's in the hospital system, but we are not at this point yet. But I think that there will be some other like processes to do that. And of course, like users could do like different things. So, for example, like write they. I mean, we cannot regulate how users will use this data, but like from our side, we don't have access to what users actually checking, anonymizing. I hope it answered the question.
Yes, thanks, Olga. And
Thank you.
I think that much of the, not misunderstanding, but may come from the idea that, as I understand your platform, the idea is that organizations will purchase it and have it installed in their premises, which means that it's not that you will operate this platform outside organizations, but again, it is something, the way that the platform can be purchased, and the adoption model is something that the customers can also have a say, and they will have the increased say there on how they would like to proceed to the adoption. Now, the second startup is TermX, and actually the product is TermX. The company is Helex, and TermX is an open source knowledge development, management, and sharing platform, including a terminology server, wiki, model designer, transformation editor, and publishing tools. And the primary development goals of TermX have been to enhance interoperability and improve terminology accessibility, simplify data model design, and facilitate data transformation between models based on the latest health standard FHIR. So, Igor, the floor is yours.
Thank you. Let's take a share. Okay. I hope you can see my presentation. First of all, some words about me. I work in healthcare IT for 30 years and participated in development of 3 hospital information system and also 3 national system in Estonia, Lithuania, United Arab Emirates. And I also have many projects in different countries like Moldova, Uzbekistan, Georgia, Montenegro, and so on. Right now, I am also WHO e-health interoperability expert and belong to WHO technical work group. As Adamantas says, today I will speak about Termix, and it's about interoperability. And when we speak about interoperability refers to the ability of different systems, devices, and applications to work together within and across organizational boundaries. And you know that different systems often use varied formats and standards, making it difficult to share data seamlessly. In this case, interoperability ensures that data can be exchanged and understood. But at the same time, we know that it's very difficult to achieve it. There are different communication breakdowns, questions of efficiency, questions about quality of data. So actually, when we don't have this proper interoperability, it's very often lead to reducing of cost, manual processing, errors, and so on. So for this reason, in Europe, we have the so-called refined e-health interoperability framework that help us to organize different levels like legal, organizational, semantic, and technical. And my work and my product, it's mostly about such topics like developing of terminology, developing of logical and clinical data models, adapting of interoperability standards, designing transformation between data models and between different standards, creating knowledge-based and publishing of this standard and implementation guides. There are many different tools that can help you to publish terminology like onto a server, to develop logical models like Simplifier, but there are no tools that allow to do all these things together. Allow to make it easier and understandable for end user, like providing open source, no cost, and high quality tools, and also with multilingual support. So it's actually lead us to this problem when we should exchange this data between organization A and organization B, and we cannot do it because we don't have some proper contracts and ability to exchange this information. For this reason, during my PhD thesis was developed a new open source platform to harmonize terminology and support interoperability between different institutions. It includes terminology server, wiki, model designer, transformation editor, and tools for authoring. We will look a little bit in every of these tools. And first, maybe most popular and most known is terminology server that help users to create, store terminologies from different sources. It supports management and translation of SNOMED concept, LOENC. It have support for ICD, and it also supports your local or your national coding. It based on clinical terminology services release tool, such a standard, and you can see how it's presented. And of course, it supports versioning, validation, and authoring of terminology. Terminology server used in 3 countries. I will mention it later again. The second important part is modeler. So very often, if we want to exchange data between different systems, first of all, we should design some models. And this tool help to design it using graphical interface, using FireJSON or shorthand fish notation. So many different notations that this tool help to transform from one view to another, to help end user to design model that suits for him or for her. The third important part is transformation editor. And what you can see here, it's a transformation designer when you can have source model and target model, and you can design your transformation workflow, different transformation rules, how one field will be copied or transformed to another. So here, for example, time will just copy it. When practitioner code will be transformed in this way that there are some append operators that end some string and take practitioner identifier to create this final field. Again, I will demonstrate it in a real application. As a result, we have source, we have some transformation rules or structure map, and using this transformation engine, we can replace. We can transform source instance to output instance without any programming. And now we will take a small look into application. So first of all, you are welcome to use demo ThermXWork if you want. After opening, you will navigate it to landing page. You can see there are many coding systems that created by people from many countries. You see that there was somebody tested and created many code systems. We can look for different systems, and the simplest one is, for example, administrative gender coding system. It's something that specify concepts with different terms, with different association, translation, and so on. So, for example, here you can see administrative gender with different versions. There are some versions, there are some concepts inside of this version. You can look it, you can change it, add a new concept, manage it according to FHIR specification. You may have different types of downloads. You can have Excel, JSON, whatever else, or special file presentation. We can also look, for example, into ICD. You can see here many different editions, like ICD-10 of different versions, Latvian, Uzbekistan, Czech editions. This is Estonian edition of ICD-10. So it may be, let's say, hierarchical. It may have many different languages. We can go through this hierarchy. We can specify languages we interested in. We can specify which attributes it should display. So this is like a tool that help us to manage this. There are also different import possibilities and so on. The second important part, this is value sets. It's part of FHIR specification, and FHIR is the most popular interoperability standard right now. So you can specify different rules, which concept from which terminologies should belong to value sets, and it create different expansions so that may be used in the application. Third topic, interesting topic, it's this FHIR mapping language and transformation editor. So you can see here one example how to transform OMOP measurement concept. So this is model of OMOP measurement with such attributes from one side, and you can see on other side there are FHIR observation and many different rules how this data should be transformed from one view to another. And here you can also validate. So, for example, transform and check does our validation work. So such instance converted to such OMOP instance converted to such FHIR instance. And Termux provide this visual editor. So, for example, you can here, I will just demonstrate something very simple. For example, I can just bring this line from one unit source value to node. It's not, let's say, very useful and not very practical, but just to demonstrate how it works. Or I can add some operator and make some transformation. You understand that it's not very real example, but you can do it. So this is a tool for data transformation. And maybe final view, this tool also provide ability to create like knowledge base or thesaurus. Right now you can see some wiki project with different descriptions. You can create, for example, different tables. There are information about related pages, about related terminologies. You can embed these data models into your page, make it easier and explainable. Again, you can see all this relation. You can make different external links to support different operations. So this very, very short overview of Termix. Terminology, like first of all, for description of code system, different value sets, data transformation. It's also provide concept maps or map sets. It provide ability to manage SNOMED editions, publish data, publish implementation guides. But yeah, for that we need more time. I will continue with my presentation. So just to repeat, Wiki enable well-formatted content creation with links to other pages, to terminologies, to transformation. Publisher allow us to create implementation guide and share terminology with GitHub repositories, or read into GitHub repositories, or synchronize this data with other terminology servers. This tool support Fire API for terminology server, for structure definition and maps. It also provides support for Fire shorthand fish syntax, integration with GitHub and other terminology services. This is open source that is built using Java and Angular. There are also Postgres database and many other external tools like Snowstorm server for SNOMED. And as I said, it's this tool used, first of all, terminology server used in Estonia, Lithuania, and Czech Republic, and maybe totally customized, so you can see how it look in Estonia. This is example of integration to Lithuanian portal. And to summarize this presentation, I want to just say that Termix is an open source platform that is developed for semantic interoperability and knowledge management. Again, it includes terminology server, wiki, model designer, transformation editor, and tools for authoring and publishing. This tools was developed to reduce needs for technical specialists because most people in healthcare domain does not have very deep knowledge in standards, and very often they need like technical personnel. So this tool hide complexity of standards and provide ability to build terminology and models using this visual interface. Yeah, and it's support process automation and publishing of implementation guides. You can go to Termix.org. You can look for different Termix papers. For example, paper in SoftwareX describe it in more detail. And that's all from my side. If you have questions, I can try answer to them.
Thanks, Igor. I see also there was a follow-up comment from Helder Paleira on the presentation of Olga, and that he mentions also, because it's an open source tool, that Helder commits that he will explore the tool later on. So if there are no other questions, we can proceed then to the third and last one, which is Gunnar and Smart EHR, so Smart Electronic Health Records.
So I hope my slides are visible.
Yeah.
And yes, what is Smart Electronic Health Records? Actually, if Igor's presentation of technology is mostly ready, Igor, and also technologies that is used by companies and so on. I'm talking something that is not ready. I will show still some demo, but I explain why we are doing this. And actually, I titled this Private Decentralized Content Addressable Storage Network-Based Health Data Management System for primary and secondary use. And actually, who is managing in smarter, let's say, based on smarter ideas, the person is managing. There are lots of questions, but still, I try to convince that what we are doing is not absolute nonsense. And this is actually the smarter team, me and Professor Peter Ross. And then we have also Tanel Ross, brother of Peter Ross, who was worked 5 years as Chief Executive Officer in Estonian Health Insurance Fund. So let's say Peter is practicing doctor and developed Estonian health system. Tanel is a businessman or working in health business, funding Estonian hospitals and such kind of things. I'm a software engineer. I worked 30 years in developing laboratory systems in Germany, in United Kingdom. So, and our PhD students, some of them are already graduated, some are graduating soon. And actually, the biggest part of this is eMedLab. And we believe this is Estonian biggest or largest e-health research center. Currently, we have more than 10 active PhD students, some 20 researchers from various, and we are playing. We're dreaming about something, how to make health data openly accessible, personal health data. We see personal health data something like real physical world. We want to understand to make healthcare better. I don't talk too much here about what is primary and secondary usage, just comments that primary use is if someone is using personal health data for diagnosis, treatment, let's say lifestyle, health or illness prevention, such kind of things. Actually, this we think is primary usage. And normally for primary usage, we need some kind of identifiable data. We must know that this is this person behind. The second is secondary use. And normally we need here either pseudonymized data or maybe even anonymized data. And this is just one use case we are playing sometimes at who might be interested in such a system that person is able to share, sell, donate, whatever, to companies his personal data, and we designed this based on pharmaceutical companies. So it means that maybe someday pharmaceutical company are going to some kind of internet tool looking for possible persons who are interested and who have some kind of properties for clinical trials. And actually, when we started the research, mostly this is Thomas Clementi, our PhD student, and he found that actually we have three challenges with health data. First is accessibility challenge. We want health data to be protected because they are sensitive data. At the same time, we want to use those data for medical research and for instance, machine learning and AI development. So this is one challenge. The second is comprehensiveness. Actually, I'm a living example of this comprehensiveness. 10 years of my health records are in United Kingdom, 5 years in Germany, and 55 years in Estonia. And those data are not combinable together. No Estonian doctor knows that I had what it is, stroke in Germany, and such kind of things. And the ownership is actually, we always claim that, okay, those are your data, you are the owner of this data. But still, how much you can prevent, for instance, big data leakages in France recently, last year, or in United States. And we might talk that okay, we have very good and really good security system, and we have specialists and so on, but bad guys are also experts in what it is, breaking those systems and so on. So, and this is actually the big picture, what we are dreaming. We don't want to change the infrastructure. We don't want that we are building a new system. We just want that maybe my data are in my hands. For instance, all my data from Germany, from UK, from Estonia, combined somehow will show my real health picture with all the history, what electronic health record should be. And now when I'm going to see my doctor in Estonia or to see my doctor in Germany, I'm just able to present my data semantically interoperable way to this hospital, and it integrates nicely to this hospital system. And now I'm able to maybe share my data with some research company. So this is the idea. So, and now this is a current solution we are playing. Behind of this is so-called decentralized content addressable storage network. And actually, if someone is interested, go to look Ethereum Swarm. This is not blockchain, but this is built on top of blockchain. So we can think about something like if blockchain is a central processing unit for distributed computing, then the swarm is actually hard disk. So and both are needed for computer to be operatable. And now all the data are here owned by person, yeah. And if person and they are insecure, it's not server. It's not so that all your data are in one server, and if someone is breaking the server, all your data will be there. Actually, your data is split again, different servers. Actually, currently the unit is 4 gigabytes. No, 4 kilobytes, not kilobytes. I know 4 kilobytes is also a big one for health data. So some security must be, and they are there, and we are working for this security. And now, if I'm going to see what any doctor, I will present some kind of magic key, and the doctor is able to see all my data somehow. And the same, I will make from my my health data, I will make de-identified copy, and I'm able to share this for some kind of research company. And I know who is a research company who is using my data. I even have some kind of control how they are using my data. This is actually the picture what the Ethereum swarm is. There is a link as well. And it is some electronical paper shredder. You put your data through the shredder, the small pieces, and every piece is securely stored in some node, in somewhere in the world, in internet. And only the magic key helps you to bring your data back to the computer where you have the key, or to the computer of doctors if you share the key. I know there are lots of issues, not lots of problems we have to solve, but still we are working on this. Now we have actually we designed 4 tools. We think that first we need some kind of smarter life for persons, so that persons can manage the health data. Then we need some smarter scribe for doctors, so that doctors can somehow use those data for diagnosis and treatment. Then we need some kind of smarter share, how to semantically, interoperably share personal data with hospitals and with research companies. And we need some kind of smarter use, how researchers can use those data for secondary use. So we got research funding, and we are currently implementing, this is 2025, 2029. And what we try to do during this, we try to evaluate the feasibility of such system in clinical settings and in medical research. And we must start this project. Currently, it's preparation. 1st of January 2027. So it means we are currently implementing the system. The problem is not in implementing the technical part of sharing data. This we already we have a prototype. Currently, we are developing the system, what the patients can do, how the data are going to doctors, and so on, such kind of. We are designing user interface part, actually together with doctors, researchers. And now I'm going to demo part of my presentation. Stop sharing. And now I have to share again. And now I will share my screen. And actually, I will share. Yeah, this is. So now you should show what we did and what we are doing currently. The beauty here is that that also system is designed so that we have one code for all. For currently, you see here the web page, and you see also it in Android emulator. We also have tested it in real Android equipment, and also in as a Windows desktop application, also Mac application, and also Mac phone. So, and what we are doing here, we are designing some kind of what the person can do with his data, showing some summary, entering some data, getting some notification, both from automated, let's say, avatars or some kind of algorithms, but also doctors can send notifications. Then you can chat with doctor, but currently we also implementing. I'm not able to show this, but we are working for possibilities that some AI-based solution is emulating or acting as doctor, so that the patient can always connect with doctor, but definitely under the control, because the system must not. We have here also some kind of what it is, warning that this app does not replace medical advice. But what we are doing is that doctors are always able to monitor what the system did and what were the requirements and so on. What the system does. And okay, the same is working also here in Android applications. We are also working to use some kind of let's say video avatar. So various things. We also are working how we can how those let's say how we can ask prems and proms. So what the patient is feeling about how the treatment is going, or what is so there are some kind, so that doctors can ask questions how the treatment is going. So this is what we plan. Also, we are planning that we can combine all the data from hospitals, from various smart devices, also from home, medical devices. Also, patient can enter data, and to put all this together, and to put it together so that, okay, we can share this with hospitals. If they want SNOMED, okay, then SNOMED. If they want LOINC, ICT, okay, ICT, FHIR, okay, FHIR. If we need OMOP, then OMOP. So if you see, we all what Karen today, also Igor and Olga explained, the idea is maybe they are all going here inside, and maybe it comes sometimes some tools that we as patients, we as citizens, are actually masters of our data. We will get different kind of smart advice from AI-based decision support systems. For instance, yeah, Gunnar, all is good, but maybe you have to see a doctor. Maybe you have to make, let's say, cholesterol measurement, because you haven't done this last year. And then I go to doctor, I see my data, and the doctor gets some kind of advice that, okay, look for this guy, those and those data, maybe there is something you find, and maybe there is something you have to help this person to get rid of this health issue or something. So this is my talk, and thank you. I hope that
thank you. We thank
that you got
you,
something,
Gunnar, and I very much appreciate also that you used the opportunity to mention personal experience, first-hand experience, which are in many cases very, very important for us to shape our ideas and to give them a test. I also see that Helder, you may be the hero today from the attendees, that you were extremely participatory, and I very much appreciate it. And I think that this is also the idea that it's not only of only listening to what we are presenting here, but also taking part, and what you provide there as a link about this My Health, My Hands EU project is for sure relevant, and especially for all of you, because now we are approaching the end of this demo day. To all of you, but you, Helder, were especially active. Please feel comfortable to stay in contact with us. The slides will be also available later on. Gabriele will see so that you can find them in the portal, in the platform. And the important thing is now feel comfortable. If there was a talk or a person that attracted your interest, feel comfortable to directly send an email to them. And this is what is the most important thing, the follow-ups. Otherwise, the events are good, but the follow-ups are the most essential part of why we hold these events. So I don't know if, Leonie, you have anything that you would like to add from your side. And we have mentioned that there are 3 unicorns from Estonia. I think that there is an obsession with financiers mainly, that they would like to see every startup as a potential unicorn. But in real life, no one has seen a unicorn, while we have seen many other different animals. So this obsession that in many cases people have about unicorns is not helping at all. And in many cases, it's only linear that startups grow. And this is also the healthy way to grow. Otherwise, if you attract attention and in 1 month you get all the funding that other people may have not been able to raise in all their lives. So it's for sure that one may not necessarily succeed in what to do with this funding. So for us in ShiftHub, it is important to invest in the ecosystem approach, which means that it will be very positive for me if we start inviting startups in our future research actions. Okay, so Leonie, you will have the final word for today's meeting.
Thank you, Adamantios, and also thank you all for, on the one hand, joining us for today's ShiftHub Demo Day, but also thank you all to the presenters for the inspiring demonstrations. Events like today's are very vital for strengthening Europe's innovation ecosystem. As we have seen, they bring together our innovative ideas, the innovators itself, the researchers, and especially all the stakeholders across the value chain, which is very important to get the feedback and also to get innovation in the market that really fits the needs, which are dependent on the different stakeholders' perspective. So I am very impressed from the different demonstration and how WiseSpace, TermX, and Smarter are not only concepts, but real solutions enabling GDPR complaint data use. I was also very impressed by the semantic interoperability and the secure personal health data ownership. And this also represents how these tools are significant steps towards a more connected and patient-centric healthcare ecosystem across Europe. So thank you again for presenting today, for demonstrating it today, and also for the great ideas you are trying to get available for everyone. To all the participants today, we encourage you to stay connected with the ShiftHub ecosystems, to explore collaboration opportunities in the marketplace, and to continue, of course, the discussion beyond today's event. As Adamantios already said, today's event should be only a starting point, and it's also great to see that you already start connecting with each other. So continue this discussion and stay connected. Just for you to know, we are currently planning another demo day in February, so stay tuned for upcoming events either on the community platform or on the ShiftHub website. And other than that, on behalf of the entire ShiftHub team and our partners at the University Hospital Cologne, thank you once again for being here today with us, and also to our speakers for presenting their innovations. So that's it from my side, and then enjoy the rest of your day.
Bye-bye. Bye-bye.
Bye-bye.
Bye-bye.